So this is the second part of creating an iterator for our linked list. One thing I want to mention is that I missed one important part in developing the node iterator class. Notice that the node pointer that's inside of our iterator class is actually a private variable. So we would need to be able to access this actual variable. So we could do that by creating an accessor, or we can do that by creating a constructor where we can pass in a pointer and set our current member variable equal to whatever pointer was passed to that constructor, right? So what I mean is if I was to create a constructor called node iterator, then I would just give it a member variable node class t pointer, and this would be our initial pointer. Excuse me. This would be our initial pointer inside of our linked list, which is of course the head, right? We could also overload that with just a empty constructor or a default constructor. And so let's just take a look at what that would actually look like. So if we were implementing our default, all we would need to do is just set current equal to the null pointer. Right, that's just a way to say, hey, we're not doing anything. We're just going to create a node pointer, and it's gonna point nowhere. So let's go ahead and create that. That's just gonna be very simple. Node iterator, and then here we'll just say current is equal to null pointer. All right, and then if we're gonna overload that so that we can actually pass in a pointer, then we can just say node iterator, node iterator. This one takes a node pointer as its argument. And then we just simply say current is equal to initial. And I'm going to show you why we need to do that right now. All right, so that completes our actual node iterator class. So now let's actually use that node iterator inside of our linked list. And so right now I'm not going to write out the entire linked list because you should already have a linked list developed. I'm just going to write out the additional functions that you would need to add to your linked list in order to have a iterator work with it. So let's look at our class, and we have our class list. Of course, let's not forget that this is a template class. All right, and inside our linked list, we have our public. And of course, in our public, we have all our other functions. We're going to create a few new functions. So one thing that we have to do is we will need to have a iterator type inside of our class in order for it to use it for the standard template library. So we're going to just go ahead and type def our node iterator so that it has a new name, which is going to be iterator. So we'll do node iterator, and this is a template, so we say node iterator t, and then we're just going to call this iterator. So now whenever I write definitions inside of my linked list class, if I say iterator, that means I'm referring to node iterator t. All right, so in order to put the iterator inside our linked list class, we just need to put two functions, right? And the first function is going to return an iterator. And of course, that means it's returning a node iterator t type. And then we're just going to call that begin. And basically what this will do is it will point to the beginning of our list, which is as we all know, it's our head. So this will point to the head. Then we need another function that's called end. And this basically points to the end of our list. Which we all know the end of our list is actually the null pointer. All right, and so that's all we need to do to be able to have an iterator inside of our linked list class. All right, so let's just go ahead and write the code for that. And the code is pretty simple. All right, so if I say iterator, of course, this is part of my linked list class, so I'm gonna say list t. Of course, since it's a template, I have to put my template here. All right, so linked list t, this is called begin. Begin does not require any arguments. And basically what we're gonna do is we're gonna create a new node iterator pointer. Excuse me, actually it doesn't even need to be a pointer. We're just gonna create a new node iterator, which of course I'm just gonna keep repeating. That means it is actually a node iterator t, because that's what we type def our iterator to be. So we're gonna say iterator, and we can just call it whatever. I'm gonna call it temp. And since I have a constructor, right, I created a constructor that will take a node t as an argument, which is what I just wrote here. Then all I'm gonna do is just pass my head to that constructor, and that creates a new iterator that is pointing the current to the head, right? Inside our node iterator, we have a variable called current. If I call this constructor, the node iterator constructor here, then I'm gonna call this function that we just wrote here, and this function says to just set current equal to the node pointer that was passed to it. And so since I'm passing head to that constructor, that means that current will point to the head of our linked list. All right. And we also created a default constructor, right? This default constructor here. And this default constructor says, where do we put that default constructor? Looks like right here. The default constructor says that if there's nothing passed to it, then we just point it to null pointer, right? And null pointer is pretty much what the end of our list is pointing to. So to implement our end function, it's gonna return an iterator. All right, and then we're going to go ahead and put our class scope resolution, which of course means that we need to put our template here. And then I just named the function end. And end is basically gonna do pretty much the same thing that our begin did. We're gonna create a new iterator, and we'll call it temp. And this time, since there's nothing that we're passing to it, we're just gonna call the default constructor. And then we just return temp. And it looks like I forgot to write that here as well. Inside our begin, we also return our temp. All right, and so now that sets an iterator. This begin will create a node iterator that is pointing to the head of our list. And this right here will create an iterator that is pointing to null pointer, which is equivalent to the end of our list. All right, so now let's go ahead and use our iterator. right? And to be able to use our iterator, basically, all we need to do is go into our main function. Right, if we're in our main function, then we can create our iterator by just saying link list, excuse me. And let's say we're going to create an integer iterator. Basically, what this is doing is saying find the data type named iterator that is in the scope of our linked list, right? So in that case, that will be the type def that we just created, right? And then the next thing we do is just we create a name for our iterator. I'm just going to call it iter, right? And so now I have a new iterator declared, right? But the iterator is declared, but there's really nothing happening to that iterator yet. So let's go ahead and write some code to actually use that iterator, right? So the first thing that we want to do is create a for loop. And then the first thing that we want to do is we want to set our iterator equal to the beginning of our list, right? And then we just wrote a function to do that, right? We will just say, well, it looks like I didn't create a list. Let me go ahead and create a list as well. List int. This is going to be our list. I'm going to call it list. So now we'll just say iterator is equal to the beginning of our list, right? Which is list dot begin, right? And as you remember, this begin returns an iterator type that is pointing to the head of our list, right? And then the last thing we want to do is, the next thing we want to do is say, while the iterator is not equal to the end of our list. Oh, excuse me, the end of our list. So we have to say list dot end. And if you remember in our code, end of our list is pretty much pointing to this end function. Pretty much says it's pointing to the where's that definition? It's pointing to null pointer, right? That's what end of our list is doing. So we're saying while the iterator is not equal to null pointer, that's basically what this is saying. While iterator is not equal to null pointer, then we want to increment our iterator, right? So we call the plus plus operator that we just implemented in the last video, right? So that means that every loop is going to iterate, it's going to increment the iterator to the next address, and that would be the next thing inside of our linked list. And then at that point, now we can do something with our iterator, right? We want to do something with the data. Say we want to see out the data. We can say see out. And now we want to dereference our iterator, right? And remember what the dereference operator did. We overloaded this, and this actually returns the data that the current member variable in our iterator class is pointing at, right? And so that will pretty much iterate through our linked list. All right, so that is pretty much the second part of the linked list iterator class. All right, thank you very much. And you can use the same secret word as the previous video.